Assalamualaikum warahmatullahi taala wabarakatuh. And good morning or good evening here. I'm in UTM. So as promised, I have tried to copy some examples from the previous test and final exam related to chapter 6, which is the integrated circuits. So here, I think I have 4, 5, 6 examples that I will show step by step how to answer the questions. Okay, so without further delay, let's see how we can do this. A few examples, I think maybe the step-by-steps are important on how to solve the questions. Example here. Example number 1. Analyze the circuit in figure Q1, obtain the truth table and next term expression. So, okay, based on the picture. So, the example of last year test 2 question on multiplexer. Okay, so the question asks about to do the truth table and to fill out the next term. Okay, anyway, okay, so on this, in these questions, so you have 4 input here, A, B, C, D, and from that, you need to do the truth table. So the truth table, okay, A, B, C, D. Okay, so as I mentioned before, I like to do this. Okay, the 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 1, 1. 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1. 1, 0, 0, 0, 1, 0, 0, 1. Okay, I hope it is sufficient here. 1, 0, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. Okay. So from this, you need to derive and put all the values as the input and output. Okay, first input output, AB is 0, 0. So the output here is C and D. So CD goes to the NOT gate and NAND gate. So here 0, 0, it will go to 0, 1. 0 and 1. Okay. So you need to derive one by one. 1, 1. So 0, 0, 1, 1, 0. And then after that, so it's just to test you on the get none. Then after that, AB is 0, 1. So 0, 1, everything is 1. And understanding using the multiplexer. Then after that, 1, 0. So 1, 0 is D. So you follow all the value of D. 0, 1. And next is 0. So everything is 0. So here, I think how many marks? So when you fill out this part, so there are a few marks. And then after that, okay, so you just need to write F, A, B, C, D. Since, okay, is the max term, so pi m. Okay, what is it? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you have number 3, you have number 8, 10, 12, 13, 14, 15. So you just need to write out 3, 8, 10, 12, 13, 14, and 15. Ta-da! So this example number 1, I think will provide 7 marks out of, I'm not sure, for that test 2. Okay, let's see another example here. So, example of comparator. So, comparator here, a 2-bit comparator, create the truth table or between 2 digits, A1 and A2, A1 and A0, B1 and B0, and the output is only X2 and X1. X2, A equal to B, X1 is A equal more than B. Okay, so it asks you to get the truth table. And next, find the simplified equation, the Boolean equation, draw the schematic, and using the NaN gates. So many instructions here. Okay. Okay, so this is the 2-bit comparator. So you know you have only 4 input. So let's have here A1, A0, B1, B0, and how many output you have? So you have 2 output, X2 representing the A equivalent to B, and X1 representing the A bigger than B. So you need to fill out. So when you want to draw the truth table, it's important for you to know how many input and how many output. So these are 4 input and 2 output. So let's put the input first. You cannot avoid using the truth table. Okay, so now we compare. If it is equal, okay, A1, A0 is 0, B1, B0 is 0, so X2 will be equivalent to 1, else is 0. So here you find 0, 1 is equivalent to 0, 1, so is 1. And here, again, 1, 0, 1, 0 is 1. And here, the final one is 1. Okay, so that's for A equivalent to B. For A bigger than B, so you need to check one by one. So, all right. So we have here 0, 1 is bigger than 0, 0. Okay. And here, so we have here 1, 0 is bigger than 1, 0, 0. 1, 0 is bigger than 0, 1. Okay. And here we have 3. Okay. 0, 0. 1, 2, 3. So 0. Okay. All right. Then, okay, it asks for a simplified equation. You cannot run away of using the K-map. So let's see, we draw the K-map here for both output X2 and X1. So mana nak lukis? So we can make this part bigger. Okay. Let's draw the K-map. For the first one, for the what? For the X2. Okay, for the X2, A1, A0, B1, B0, 0, 0, 0, 1, 1, 1. Be careful here. After 0, 1 is 1, 1. So 0, 0, 0, 1, 1, 1, 1, 0. So let's fill out the, and okay, we put also for the x1. Okay, so this is x1. So we have also a1, a0, b1, b0, 0, 0, 0, 1, 1, 1. You write it here. It's really important to write the digit here just to avoid mistake. Okay, so now we put all the value from the truth table inside the K-map. So the first one 1, 0, 0, 0, then 0, 1, 0, 0, then we have the 1, 1, 0, 0, and 1, 1, 1. No, sorry, I make a mistake here. Mana aku tengok tadi? Okay, this is 0, is 0, is 1, is 0. Sorry, my mistake here. Cannot be wrong. Okay, A1, A0, B1, B0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Okay, so this is for the X2. So, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Okay, so you have the 3, 4 individual value for the x2, and for x1 0, 0, 0, 0, 1, 0, 0, 0, 1, 1, 0, 0. No, again I make a mistake. 1, 1, 0, 0, 1, 1, 0, 1. So this 1. So here you can make a 4 number in one group. So this a 2, and here another one group. Okay. For the x2, the Boolean equation we can get here is a1, a0, b1, b0 is all is bar 0, 0, 0, 0 plus a1, a0, b1, b0 in only a bar, b bar plus 1, b1, a1, a0, b1, b0 plus, okay, so here be a1, a0, 1. And for the x1, okay, x1, the 4 number in one group is a and a bar, a1 and b1 bar plus a0, b1 A0, B1, B0, bar bar, plus A1, A0, and B0 bar. Okay, so this you can get from the Boolean equation. Now, okay, it asks you to use from the schematic using the NaN gates. All right, using the NaN gate, I'm trying to see. Okay. So we need to see the output. Find the simplified equation for x2 and x1. Draw the schematic for x2 and x1 using NaN gates only. All right. Okay, let's say we solve for x2, x1. Okay, we need to draw for both x1 and x2. So x1. Okay. So you have the A1, A0, B1, and B0. So the first one is A1. So you have the A1 and B1 bar. So it goes to the get NaN. Get N. Supposed to be like this. Okay, get N. And then you have the A0, B1 bar. B1 bar and B0 bar goes at the input and goes to here, and we have the A1, A0, and B0 bar. So you have a bubble here. So it goes to the get N, and then everything is goes to the get OR. Okay, so please note that, okay, please note that the question asks to use the NaN gates. So here we need to convert using the conversion. For example, okay, so if we have the NaN gate here, so it is equivalent to not AND gate, this is not NaN gate, is equivalent to so you need to do the modification based on this change. So because the question asks to use the NaN gate, you need to do the conversion. So here you can add bubble here, bubble, bar and bar, so it's neutral. So bar and bar here, and bar here. So at the end, okay, so you can have the new figure here. You have the, okay, AND gate. So you have the NAND gate here, and you have another NAND gate here. Connect to the, now the OR gate, you can, so this not the OR, this is not correct. Okay. So it is the change right now. You can have this. Okay, NAND gate. So this formula, this figure change can be changed between the NAND gate to OR gate or NOR gate to AND gate. So vice versa. So the correct drawing for this is, okay, A1, B1, A0, B1, B0, A1, A0, B0. Okay, so this, and you put the X1. So then you can get, I think, how many marks, I'm not sure. So this for X1. So you need to solve for X2 using the same change. So it's very important here, because some question ask you only to use NAND gate and also maybe NOR gate only. So this be asked for the question in the test 2. Let's see another example here. So this is from final exam, last year final exam. Okay, construct, based on the figure, construct the truth table and write the Boolean equation. Okay, so I think this one is very easy. Okay, so because you have only okay, you can make a simplified truth table here, so that you can only have the one selector here. So F is equivalent to B when S equivalent to 0, and F equivalent to AB when S equivalent to 1. So here you can have the Boolean equation of S bar B plus S dot A B. So it's just a simple solving, maybe 2 marks question. Okay, so this is very easy. So just to test, this one is everything in the slide. Lecture slide. Okay, so here another example, 5 marks, or using the multiplexer here. So you relate to this question. So, all right. Okay, given the Boolean expression is given, implement function Z using 8 to 1 multiplexer. So show the connection. All right. Okay, first we look on the Boolean equation here. So Boolean equation here have four input and one output. Consider one output Z. All right. And first step, of course, you need to do the to derive the Boolean equation, the truth table. But before that, so let's derive this equation. Okay. So you have the ZABCD equivalent to AB D bar. I cannot write. AB D bar plus BC D bar plus, okay, so this exclusive or exclusive no. So exclusive no here is special case. So we need to enhance it. So we have the AB bar plus A bar B. So everything is right. And then okay. Alright. I want to solve this first, this part. So this part can be enhanced further, which is you need to know the theorem de Morgan. Okay. A B bar dot A B bar. So then after that you make A B bar and A bar B. Okay. Times C equivalent to A bar plus B plus A tambah B plus B bar times C. So here you need to enhance. A bar times A is equivalent to 0. B times B bar equivalent to 0. So what we have here is A bar B bar C plus A B C. Okay. And here, okay, you will have A B D bar plus B C D bar plus A bar B bar C plus A B C. So here you need to enhance it using the standard Boolean equation. That means you need to enhance to have all four input value before you put it in the truth table. But to shortcut, to make it shortcut, so okay, so is 1 x. So C is not exist. So C can be 0 or 1. So D bar is 0. So here A is x. A can be 0 or 1. B, C, D bar. And here A bar, B bar, C, and X, D is 0 or 1. So actually you need to enhance it, okay, using the standard Boolean equation. So that means all components have A, B, C, and D. But here, I just want to make it shortcut. Okay, so now you know that. So we put everything in the truth table. Zero one zero 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 one zero one zero one one zero zero one 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 1 0 0 0 1 1 0 1 0 1 0 1 1 and 1 1 0 0 1 1 0 1 1 0 1 1 1 1. Okay, now we put all the value. Okay, 1 1 x 0. So 1 1 x 0 is here. Then x 1 1 0 1 1 0 is here again, and another one is here. Then 0 0 1 x 0 0 1 x. So we have here, and 1 1 1 x. So we have here and here again. So others is 0. Okay, so we have complete the truth table. Now, okay, please note that, so we have 4 input. So supposed to be, to make it easy, to use the 16 to 1 multiplexer. But here you only have 8 to 1 multiplexer. That means you need to sacrifice one of your input, that is supposed to be the selector, okay, because you only have A, B, C here, right? So that means D need to be a direct input to the multiplexer. Okay, because you already written here A, B, C as the selector. All right. So in order to do that, you need to cut each part into 2 parts. Okay, so you need to compare the input value to the D. Okay, so that means Z is equivalent to this part. Z is 0, so Z equivalent to 0. So this one, Z equivalent to 1. It doesn't follow the D. So this is Z equivalent to 0. Z equivalent to, okay, because of D is 0, 1. Z is 1, 0. So it is reverse. So this D bar. And here Z equivalent to 0. Z equivalent to 0. And again here, D is 0 and 1. So Z is 1 to 0. So again, it is reverse of D. So this bar. And finally, Z equivalent to 1. And when you have the value here, okay, so you just put all the value here. 0, 1, 0, D bar, 0, 0, 0, D bar. I missed something. 0, 1, 0, D bar, then 0, 0. Also, this one is supposed to be D bar. This one is 1. So this is, you need to ground it to make it an enabler. All right. Okay, next question using the same question. So you need to use a 4-1 and 2-1 marks. That's mean previously you are using the 8 to 1 marks. So now you need to use 4-1 marks and 2-1 marks. So that's mean so here actually you need to use 4 to 1 marks and single to 1 marks. So let's draw the 4 to 1 marks. Okay, so and the important part is, so what you want to put the value of the selector, which one is the most significant bit and which one is the less significant bit. So here for the 2-1 marks, you need to label. Okay, so you need to the most significant bit. So the most significant bit is the A. And here on the left is also the most significant bit, the A, for the B and C. So others values, so you just need to put all the value here. 0, 1, 0, D bar, okay, 0, 0, and D bar, and 1. Okay, so you can do this. So how many marks, I'm not sure. Okay, so this is very easy. But most of the students have difficulty to answer this question. I will accept here, so I will accept this. But actually, you can connect, for example, to make it, so 0, everything you connect to ground. 1 ground only. And for 1, you connect to maybe VCC. VCC, something like this. Okay. And D, maybe you have a D, you can connect directly. And if the D bar, you can put the that knot to get the D bar. Okay. So this is the final exam question. Okay. Before I end my example, so I think maybe this the last example. All right, maybe an easy question here. So figure from final exam. Figure shown that figure Q question 13 obtain the Boolean expression of f. Okay, ask you to get the Boolean expression. Construct the truth table. So we cannot run or hide away from the truth table, and then use the 2 to 4 decoder with one basic gate to obtain the same output. Okay, so number 1 is just an easy x, y, z. Okay, Boolean expression. So it is x based on this xy plus yz. So this may be just a free marks plus z x x x. Okay, so 2 marks. Then after that, you need to construct the truth table. Okay, so you know you have the x, y, z. And I will put here x, y, z. So you have the f, small f at the output. So you have 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay. And right, so we need to extend to have a the standard Boolean equation. So we have x, y, z plus x, y, z bar plus x, y, z. So it's repetition. So you need to have a x bar y, z plus x, y bar z. Okay, so you have the 1 x, y, z. This what? 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1. So 1, 1, 0, 1, 0, 1, and 0, 1, 1. Else is 0. Right? Alright. So you have 4 marks. So just that. Level 2 plus 4, 6 marks. And the final question is asking you to use the 2 to 4 decoder and plus 1 basic gates to obtain the same output. Okay, so you need to use the 2 to 4 decoder. Okay, if you can see that 74 has C139. Okay, you have A, 1A, 1B, 2A, 2B. So that means you have the two to 4 decoder, and we have the VC ground, one enabler, two enabler, second enabler. So do you have the control part on the enabler to make it either the first chip is function or not, or second function or not. All right. Okay, here you have a problem here. You have the X, Y, Z. And you know that the decoder only have two input. And here you have the three input. So that means you need to sacrifice one as, maybe as a controller. If we want to use 3 to 8, it's supposed to use 3 to 8. And decoder is much more better. But unfortunately, it's only given here 2 to the 4 decoder with two pieces of 2 to the 4 decoder only. So you need to modify this function through the 74HC139, which is the 2 to the 4 decoder. Okay, so this decoder only have two input, which is 1A and 1B. Example, or 2A or 2B. And you have the enabler here. So that means you can sacrifice one as the to make it as a controller. Okay, it's up to you whether you want to choose X, Y, or Z. So here, so it seems that, so maybe I want to choose X as a controller. Because of what? Okay, because it's much more easier to divide into the two part here, which is 0, X is 0, one part 1. X equivalent to 1 is part 2. Okay. So where we want to put it? We can put it here as a controller. Okay. So we can put the X here. Another one is we could put the NOT gate here. So that means only one decoder activate at one time. And the other part, we just put the the Y here as the input, as the MSB. Okay, it's a Y, and another one is just a Z. So here is Y. So this here is Z. This is X. The others here, you just put it as a VCC, and this one you ground it. Okay, so settle for the input. How about the output? So the output here, okay, 0, 1, 1 is activated. Okay, 1, 0, 1, 1, 1. And be careful here. So you have the bubble. The chip has bubble. Okay, and you know that this equation is based on the SOP. So you need to use the it's a get OR. Supposed to be a big get OR to have this output of F, right? F. Okay. The big get 4 input of get OR with the bubble here. So then get NOT. And actually, so this big, when you have like this, so actually you can, okay, you have the 4 bubble here, okay, of the gap 4 is equivalent to a non-gap, a single non-gap with 4 input. Okay, so you need to replace this with this, right? So that's all. I think I have a 6 example for your reference. Maybe you can refer this video to answer the test 2, especially on the integrated circuit part on the chapter 6. And also maybe you can refer it later on as an example for the final exam. Okay, so that's all. So hope you can enjoy this video. Thank you.